Hello, everyone. We'll wait for a few more people to join. We'll start in about 2 minutes' time. We will start in 1 minute time. Thank you. Okay, I think we're ready to make a start. Welcome everyone to our tonight's webinar. I'm Declan from the UAE branch of the Institute of Structural Engineers. I'm joined today by Hemant, a committee member, and Mohammed Ezeldin from, he's one of the graduate members of the Institute of Structural Engineers. I'm going to start by just sharing screen. Yeah, so just so everyone is aware, tonight's talk is being recorded, and we're going to leave a copy of it on our YouTube channel. We're going to talk about the Institute of Structural Engineers Certificate in Structural Behaviour. Just so you know, the UAE branch of the IStructE has got a sponsor, Hempel, who provide protective coatings for steelwork, including intumescent paint. So I'm just going to give a brief introduction about the structural behavior exam. I'm going to give my personal tip for how to analyze and visualize structural behavior. Hemant is also going to do the same. And then Mohammed is going to also give some advice on how to approach the exam. He's going to go into a little bit more detail about the exam setup and how to arrive at the correct answers. Anyone online, you can scan this QR code and it'll bring you to the IStructE page that's got all you need to know about registering for the exam. So I'm just going to quickly go to that web page. So the iStruct-D, this is the iStruct-D homepage. If you click on training and development and then click on qualifications, you then move down to certificate in structural behavior. And this is the main button I'm sure everyone will be interested in, register for the exam. So what is, like, why would you do this exam? Well, basically if you read this paragraph here, the certificate is an internationally recognized mark of competence that proves that you have skills valued by employers and that you have the fundamental knowledge on how structures behave. So it's about getting recognition for your knowledge, and also when you pass the exam, you get to earn the credentials iStruct-D. You can put those qualifications after your name. If you're working towards chartership, having the exam also contributes towards your initial professional development and the professional review interview. So this would be what you would get at the end, iStruct-E designation. So if we just go back to the PowerPoint presentation. So how it works is basically you register for the exam through the website I've just shown you. You can keep an eye out for this register now button. When you register, you don't actually have to decide a date that you want to take the exam. You just register for the exam. You will then get access to hundreds and hundreds of sample questions, and you can, in your own time, you can practice them. When you practice these tutorials, they give you a mark at the end, and they can tell you what questions you got right, what questions you got wrong, and it also gives some commentary on the correct answers and how to arrive at the correct answer. So when you've done that a few times, you can then set a date for the exam. So from the time you register to doing the exam, it's a maximum of 45 days, so around six weeks or so. The exam is 2 hours, 20 multiple choice questions. And yeah, once you do the 20 multiple choice questions, then you pass the exam, obviously, and you will then earn the credentials. If you have any questions at all about registration process, you can just send an email to exams@istruct-D.org. Okay, so I'm now going to give a tip on how to visualize the structural behavior. I just want to thank my colleague at Mott MacDonald, Mohammed Naziz, for putting together these few slides for me. So with this example I'm showing here, you just have a two-span beam, and you've got a point load in the middle of the first span. So when you're working out or trying to visualize the bending moments and the reactions, you may wonder, for example, reaction C, is it going upwards or downwards? So you've got a force on the adjacent span. What is happening here? So in some structures, it may be a bit difficult to visualize what direction the force is going. But what you can do is the support that you're not sure about, what you do is you imagine it being removed completely. So in this example, if this support was removed, you would end up with a one-span beam with a cantilever. And you would then have to visualize what the deflected shape would look like. And it would look something like this. You'll have some bending in the bottom of the first span. And then this cantilever, because of the curvature here, it would move up. So without this support, the end of the beam moves up. So that would indicate that the reaction at point C is actually moving down. So in order to get this point that's raised up, in order to keep that at point C, you need to pull it down. So now we know that the reaction at C is downwards, A and B is upwards, and we know the action on the beam. So we can now start to visualize the bending moment and the deflected shape. So with the bending moment, you start at this point here, and you know that because we had to push the top of the beam down, that you're going to get tension on the top of the beam. So the bending moment starts moving up in a linear line up across here to the support. And then once you move away from the support, it reduces a bit because you have a reaction on point C putting a moment in the clockwise direction. And then at B, this reaction is going up, so it's counteracting that, so it starts to reduce. And then you get the standard bending moment over like a simply supported beam here, if you draw a line from this point here to here. So that's the bending moment diagram. And finally, I just want to sort of emphasize the correlation or the connection between deflected shapes and bending moment diagrams. So in this deflected shape here, you've got tension on the bottom, which matches the shape of the bending moment. And similarly here, you've got tension in the top of the beam member, which puts the bending moment in the top of the beam as shown here. You've got this point here, which is point of zero moment, and that's actually on the deflected shape. That's the point at which the beam changes from tension in the bottom to tension in the top. So these principles I've just described, you can apply that to all types of structures. So I hope that assists you in some way when you do the analysis. So what I'm going to do now, I'm going to hand over to Hemant. Now, before I hand over to Hemant and Mohammed, I just want to let you know that both Hemant and Mohammed have both done the exam, and they both scored 100%, which was an amazing achievement, and congratulations. So if there's anyone on the call that does do the exam, and if you score more than 100%, please let us know. We'd be very interested to hear from you. So Hemant, if you can maybe share your screen, you can go through your tips.
Thank you, Declan. My screen is visible?
Maybe try again now.
Yes.
Yes, we can see your screen now, yes.
Yeah, thank you. Good evening, colleagues and friends. Before giving exam, after registration, I did around 12 practice sessions, and last 6 practice sessions, I was consistent with 8+ out of 10. And then I decided to go for this online exam. So here, a few questions are on bending moment diagram, truss, finding force in a bracing, top chord, bottom chord, to show like which are members in a compression, tension, and zero force member. I will be covering 2 questions in this session. So first question is about vibration analysis, where candidate is checked for his knowledge on use of calculating natural frequency of vibration. Yes. So here I have taken example of a, let me use pointer. So first example, I have taken a cantilever beam with stiffness EI. It will be given in kilonewton meter square or Newton mm square, mass at the tip. Why we calculate frequency of a beam? To make sure it does not fall in resonance with human walking or human frequency. So when we design a beam, we check our beam has a frequency more than 4 Hertz. So we calculate first stiffness. Stiffness is load required for unit deflection. So at the tip, if I apply P force, deflection is PL cube over 3EI. So stiffness becomes 3EI by L cube. Fundamental frequency of the fundamental equation of vibration, stiffness equals to omega square times inertia, mass. We rearrange, so we get angular frequency, which is under root K over M. And if I want to calculate in Hertz per second, I have to divide by number 2 pi. If the exam asks about time period, then we just do inverse. 1 over F is time period. So only little trick examiner can do here. Mass, he may give in a 10 kilonewton. So we have to make sure if I have a stiffness in kilonewton meter square, mass will be in a ton. So we put number and we get a frequency. You may have used this magical equation to calculate frequency. F equals to 18 under root delta. This magical equations, many of you remember. Like if I have a simply supported beam, my permanent dead load, I calculate, and 10% of imposed load, I calculate delta at the midspan. In mm unit, I put and I get directly frequency in Hertz. So this formula also very quick to use. Second example, here I have taken a beam with mass at the center, stiffness EI and mass. So deflection for a simply supported beam, we remember PL cube over 48 EI. So if my, so I can get stiffness, load required for unit deflection. I put delta equals to N, so this is my stiffness. And now to calculate frequency or time period, I put into this equation and I have a time period of frequency. One more change which can happen in exam, this mass is getting supported on a spring. It is not put on at the tip, but it is on a spring. So now I have two stiffnesses which are in series. So when I have two stiffness in series, there will be delta 1 deflection, delta 2 deflection, total deflection will be delta 1 plus delta 2. And we get equation of equivalent stiffness as 1 over K equals to 1 over K beam, 1 over K spring. So K beam will be 3I by L cube. One more twist which can happen, I can have spring at the end and mass kept on top. So now here they are, we call springs in parallel. So we get equivalent spring stiffness by adding together two stiffnesses. So like they ask one question always on calculating frequency or time period. Next questions which I have observed, it is on yield line theory. So here we have put together few cases of slab with different boundary condition. Simple edge, like it may have been explained, like what simple edge, fixed support, simple support, free edge, column. So if my Ly by Lx is less than 2, we call two-way slab where load gets transferred to both ends and simply supported. So this will be the yield line. So dark line shows tension on bottom of the tension at bottom, correct? And dotted line shows tension at top. So if I have a fixed beam, which is like Ly by Lx more than 2. So it is transferring one-way load. So this will be my yield line diagram. If I have a case where slab is getting supported on 3 columns, I find axis of rotation, this outer triangle, we have drawn using this line, which we call axis of rotation. I draw bisectors, nearly bisectors, and this will be our yield line for slab. Circular slab, which is simply supported on its perimeter. This will be yield line diagram. We have for a fixed slab. So on fixed slab, on edges also we will be having dotted line. So like practice few problem. Like once you show your interest, you will register for exam. There will be like you can give n number of attempts, and for me the n was 12, and then I went for exam. So to take us further in challenging problems like a portal frame, truss, drawing deflected shape, problems with internal hinge, like there will be always a problem on internal hinge. You will discover some problem where there will be 2 different beams and they will be telling like bending moment diagram will be same or different. So to take this journey further, I will hand over now stage to Engineer Mohammed, who also cracked this exam with 100%. Engineer Mohammed.
Okay, thank you, Hemant. Thanks a lot. And thanks for everyone for joining us today. Okay, well, first thing we need to mention, just a minute. Share. Okay, it's good to mention that the exam consists of 20 questions, 20 points. Okay, and you have only 2 hours to fill all these points. Okay, so in average you have 6 minutes for each one. But the point is that you have if you failed in 4 questions, if more than 4 questions, you will fail in the exam, as the passing rate for the exam is 70%. Okay, and each point it's 1 and 1/3. Okay, so let's try some questions for the exam from the exam. This is, by the way, from the online exams that's available on iStruct. Okay, I'll mention the link for it in the end of the slide. Okay, where you will find it many of questions you can practice, you can train yourself on the time and the exam questions will be similar, or and you will get a good points from them. Okay, so let's start with the first one here in this example. Just a minute. Okay, here.
Mohammed, just
yes.
Start sharing screen.
I start share screen.
Yes, we can hear, we can see the screen now.
Okay, so here in this example, it's it's choice. Okay, this is the first example. We have here a sample beam with a cantilever. Okay, and he just need to draw the bending moment diagram. Okay, but before we start, I just need to remind you about small things and small important things. We need to remember the superposition principle, which we will use too much in the exam. Okay, so for example, for this question, we have here a distributed load, which give me the WL squared over 8, plus I have here a cantilever, so I can divide it to two questions or 2 parts. Okay, this is first part and second part. Okay, and by accumulating them in one shape only, I'll have my final shape. This without any need to calculate any reactions or anything in this example. So just this what we will do. Okay, here we have 10 kilonewton, and this span is 2.5, so just 10 by 2.5 give me 25. And here I have this point and I have this point, so I'll just calculate WL square over 8, which give me 6.25. This is my shape. So if I go to the choices, okay, this will be my choice. This first thing. And as we notice here, all have same bending moment diagram at this point, okay, but the difference is only here. Okay, so this is the first one. Okay, second questions, and it's very important to know drawing deflecting shape, as we will have many of them in the exam, maybe 3 or 4. It depends, okay, but it's very important as engineer even to know how the building will deflect, or what is the shape of the deflection should happen. Okay, so here's this question, but before we go through, here we will start by drawing our bending moment diagram, okay, so that we will know our tension part and our compression part, and through this we will then draw our deformity shape. Okay, so here I have here this part, and I have here this part, okay, which if I draw the bending moment diagram for it, it will be 0 and 0. So when I have a member with a 0 bending moment diagram, so of course it will be a straight in the deflected shape. Okay, then I'll have here a bending moment like this. Okay, so I have here tension, and I have here tension, and I have here tension. So my curvature will go up, will go up, will go up. Okay, we will start to draw our bending moment, our deformed shape from a fixed point or from a strong point. Let's start from here. Okay, I know that here the condition is here. I don't have any movement in y direction or x direction, but I have rotation. Okay, here and here. So this point, zero movement in x and y, and here is also. So I'll just draw a curve. Okay, and here, so I have this point and I have this point. I'll just draw a tangent like this. Let's try another color. Okay, and then I'll put my second curve, so it will be like this, and here similar. Okay, then I'll have this point. From here, I know this, which will be straight line, and I'll have theta. It's very important to know that if I have an intermediate hinge, so I'll have a relative theta. So there will be a discontinuity in the slope. Okay, so that's it for this example. Let's go. Sorry. Okay, yeah, this was the choices. If I try to choose without just drawing the bending moment diagram, okay, here this is a curve, so of course this is not the answer, and this is not the answer. Here is curve, here is curve. So I'll have to choose one from this. Here I know the load is going down, so of course this will not be like this, so my choice will be this. So I just, from first minute, I cancel this and I cancel this. This will be benefit for you if you need to save time. Okay, let's go to next step. So this is the right answer. Okay, and here we will have a truss. Okay, here's a question asking about where is the tension and compression or zero forces. Okay, first thing, before we started, we have to select or our zero members. Our zero member, and what is zero member? Zero member or zero force. If I have something like this, two collinear forces, and there's another element. Okay, so if I try to solve this joint, this will be zero, as there is no any vertical force to work with this, to work against this. Okay, so this is first, and this also. If I have unloaded joint, so this will be zero, and with this will be zero. Okay. Also, case number 3, if I have a force in the same direction of a member, So the force will go directly to the other member. So this will be 0. Also, we can draw a quick bending moment diagram for our shape. Okay, as the truss even it's a beam. So just let's imagine this normal beam, this is the line, and this is our load. So our deflection will be like this. Okay, so here's will be tension, and here's our member will be in compression. Okay, so we know that all these members will be in compression and all these members will be in tension, but here all like this. So no, we need more members to can so that we can choose. Okay, here's no force, so this is 0 and this is 0 member. Okay, but here he put compression, so this is not our answer and this is not our answer. Okay, so we have to choose one of them, one of these two only. Okay, let's take a look at, for example, okay, this load, it's in compression, this point, compression from here and compression from here. So of course, this is unstable, or we cannot do it. There is no any force in the other direction to work against them. So this will be the answer. Okay. Or you can take it one by one, member by member, and choose. But I think this is the more quick way to choose your answer. And here is one of the most common and example most common questions in the exam. You will find it in any exam you will take. You will find it. Okay. Here's we have a dynamic system. Okay, consists of a load with a mass with 1,000 kilogram. Okay, and here is 5 meters in length. Okay, we need to calculate the frequency, the natural frequency of the cantilever, and given EI. Okay, so what we will do, just remember, if we have a load like this, we will have a deflection here like this, let's say D. Okay, and as per Hooke's law, P is equal K by D. And D for a cantilever like this, it's equal PL over 3 EI. So K will have this value. And from the frequency is equal omega, which is the angular velocity over 2 pi. Okay, we will just change this omega with K over M, square root of K over M, and we will have our final rule that we will put our numbers in it. We have all known, we have EI, it's given, we have the mass, it's given also, we have the length. So we'll just put our numbers and calculate it. Okay. So this is the answer. But it's important also to remember different shape and different deflection for the most common beams we see. For example, this beam this is a cantilever beam. Here we have a fixed beam with a load in the middle. Okay, here we have a distributed load, and here we have distributed fixed, and this is simple with a load. Also, it's important to remember how to calculate moment of inertia, as we will have some questions relating to calculating deflection. Okay, so it's important to know this. For example, for this rectangular section, Ix equals P by cubic H over 12. And also we will have some trussed members or some trussed beams to calculate our deflection. Okay, and it's important to know how to calculate this. We calculate about the neutral axis. Okay, which will be like this. We will have the moment of inertia of the local moment of inertia plus 2 by the area by the distance square. Okay, but this value is very small. So if we got a member, we can neglect this for quick calculation. We will just take the area by 2 by the distance square. Here also we will have some questions relating to shear, how to draw the shear force diagram. Okay, here I have distributed load from down to up. Okay, and here is a I have a concentrated load in the middle. Okay, let's go to the, as we said, the load is going from to up. Okay, and we so this is our load. Okay, let's imagine this is not like this. This is just one load. If this was only a load like this, how we will draw? This is a reaction, for example. We'll go up or we'll go down. We will go down. Okay, so here we have, this is from down to up. Okay, so here's 0. If we take a look again, okay, we don't have a concentrated load, so of course this is not correct and this is not correct. We don't have any concentrated load in the beginning, so this is out and this is out. Okay, so we have to choose one of both of them. Okay, as we said, our load will be like this. Okay, and will be a triangular shape. Okay, so it will go, this is go up, so we'll have to go down, so this is will be the correct one. Okay, as if I have like this, so it will be like this. If it was only load, one load, it will be like this, right? Okay, let's go to next step. Next slide. This one is the correct one. Okay. Okay, here is how to draw the deflected shape under this load. I have here a portal frame with a load on a intermediate hinge. Okay. Let's remember again how to draw the deflected shape. Again, we will have to draw our bending moment diagram. Okay, so we can find out what is the curvature, what's our curvature will be like. Okay, here is concave like this, and here's concave up, concave up, concave to the left. Okay, I need also to remember the boundary condition. Here I have hinged support. Okay, so delta x, delta y will be 0, but I'll have a rotation. This first thing. Second thing, I'll have to keep the relative theta between members. Okay, but remember here I don't have any support, so there will be I'll have a deformation or movement in x direction. Okay, but y direction I don't have this because in frames when we are drawing the deformed shape, we neglect axial deformation, which is in y direction. Okay, and here this is, it will be this is a rigid joint, so here I'll have, and I should have this angle to be 90 degree. Okay, and here intermediate hinge, so delta x will be a number. It's okay, it's okay at this point to move like this or to move like this. Okay, and delta y also I'll have, and I'll have no continuity in the slope. Okay, so if we try to draw, here I have my hinged. Okay, and we have to think which point, this point will go to the left or to the right. Okay, if you go to the right, let's go like this. Okay, I'll have this, this is 0, and this is my deformation or my curvature will be like this. So I'll have first thing like this point, I assumed it's moved like this, just delta, first point. And from this, I'll take a tangent, and I'll take a one perpendicular to it. From here, I'll try to draw my curvature. So this point will move a bit delta, this first thing. From here, I have this curvature because this moved like this. So of course, this will move like this. And from here, I'll have a tangent and another tangent. From here, I'll put my curve. Okay, let's see if we moved in the other side. It will we will have it in the choices. We will see it. Okay, here we move this side. This is our answer. But if we move to this side, look here, this angle, this is not 90 degrees. So there's a condition we didn't fill this condition. So of course this is not correct. Okay, and here, if we look at this, here it's assumed that here's this, there will be like this if it's fixed or something like that. Here, no any movement happened. So this is also not correct. And I don't have any condition here to say that any X direction movement will be fixed. Here's also same case. And also here, if you look under or at this point, which is intermediate hinge, okay, you will find it's almost same in slope. So also this is not correct. So our answer is this one. So just from the first thing, you can just take a look at your choices. You can just remove 1, 2, 3, for example, and choose this one. You don't have to make all the full shape before your answer. Okay. So this is our answer. So here we will mention some references. Okay, this is the QR code you can use to, after your registration, you can use it to enter, to start to practice your quiz. You'll find here the questions. Okay, and here's also, this is a structural exam YouTube channel. You'll find very interesting videos or about the exam, which helped me too much. Okay, and here's also this book. It is Understanding Structural Analysis for Braun David book. Okay, this is the link of it for on Amazon. Okay, you'll find it interesting to. It's talking about how to draw your deformed shape and things like this. It will be very useful to read. Okay, and that's it. I'll hang it to Declan. Thank you.
Okay. Thank you very much, Mohammed. It's very, very interesting, and your approach towards arriving at the right answer is very good. So, what I'd like to do now, there has been a few questions come in online. So the first one was from Mohammed, just asking if all the questions are multiple choice, or do we need to do any actual submit any calculations? So all questions are multiple choice, 20 questions. There'll be 4 options that you need to choose the correct answer. So obviously you'll have pen and paper to hand, and you'll be sketching possible solutions as you go along. Giwa has just asked about the recording of this session. So in 1 or 2 days, this recording will be on the UAE Regional Group YouTube channel. So the code of our YouTube channel is on the right hand side here, and our QR code for our LinkedIn page. If you want to keep up to date with things that are happening in the region, please just scan that code and join the group. Okay. Sajib is asking also about the recording. Prajwal has asked, is the number of attempts for the exam limited? So Hemant has responded. 1 registration for the exam, you get N online practice tens, but your live exam online and registered date time, only 1 attempt. Candidate has to pay reduced fee for the second attempt. So yes, you can, if you do not pass the exam the first time, you can do it again, but you'll need to also have pay a reduced amount. Okay, we see this some more here. Okay, how long after registration for the exam does one have to take the exam? So the answer to that is 45 days. You need to do it within 45 days. Just to note, with the bank of sample questions or mock questions that are available, 45 days is adequate time to prepare for the exam. Ahmed, thanks, Mohammed, for the excellent clarifications. If possible, please share some links for these books. So the QR codes that Mohammed put up on the screen will be available on our YouTube channel. Nazir, thank you for the wonderful session. Anonymous attendee, I passed the exam 1 year ago. What to do next? If you passed the exam, you should have received confirmation and a certificate from HQ, and you would be entitled to use the designation GI/STRUC-D. If some of that hasn't happened for any reason, you can send an email to exams@istrucd.org. Nasser is asking, can we write the exam in India? The answer is yes. It's a remote exam, and you can do it anywhere in the world as long as you have an internet connection. It's invigilated by a company called TestReach, and what they actually do is they have access to your camera, so they will be able to observe you during the exam. So once you sit down for the exam, you need to be in a room that's quiet. You can't move around. You need to just sit at your computer and do the questions. Okay, I think that brings us to the end of the session. I'd like to thank everybody for joining, and I'd like to thank in particular Mohammed and Hemant for their contribution. So we really want to encourage you to do the exam and get these so that you can use the credentials at GI/STRUC-D, and you can add it to your CV, which will improve your chances of employment. So Hemant, did you have a point you want to raise?
Yeah.
Yep.
Yes, thank you, Declan. So since we have 5 to 4 minutes, I will take a few, like one questions on trust, like it
Okay.
comes always. So just I will share quickly one question on trust, which will help candidate to know about, like we use a joint method or a section method to calculate force in bracing.
Okay.
So I will share screen to show one case like where candidate is asked to calculate. 1 minute. I will just minimize. So there will be a problem asking candidate to calculate force in a particular bracing. So we can just calculate reaction, and we can calculate directly the force in a bracing member. One question generally we find about this one. There will be this type of structures where we have X bracing, and they are clearly writing these are compression member, like these members, they cannot take compression. So we know which are the members which are under tension, so we can delete the compression members and we can calculate force in the member. So practice, institute gives you opportunity to do n number of attempts before the final exam. So like if you do maybe minimum 10 attempts, you will be definitely will perform good in the exam. Thank you, Declan.
Okay. Thank you very much, everyone. And we'll bring the session to an end with that. So thank you.